Okay, so for the 3D printing assignment, we're going to be making something that you might have to do here pretty soon, or maybe next semester. You'll probably come across is we're going to make some end of arm tooling for the grippers that are on the robots in the robotics lab. 3D printing is often used for end of arm tooling, and currently for the projects in that class, the robotics class, this is part of what you have to do. So hopefully this helps you out with that. And these are the grippers that are on those robots. And you might notice on this picture that the uh, grippers here, so the actual arms, are 3D printed to pick up these water bottles. So the first step in this process would be to know things like, hey, how do I even attach, you know, my arm, the 3D printed arm, to the gripper? And so you might think, oh, well, I'll have to pull out some calipers and actually measure the thing. No, don't do that. Look at the part number, Google it, and find the data sheet or the information from the manufacturer. So if you look up the manufacturer and the part number, then you'll get the data sheet that has the information. And here is that sheet. So if we scroll on down, boom, there's our information that we're looking for. A couple things that might be important to us are the mounting locations. So we have the M8 threaded hole right here, where it's located at on the face, as well as these pins. And then also maybe some information that we might need is the distance between these attachment points, these attachment arms, when the gripper is fully opened and fully closed. That might be some information that we need to know. If you need any other information, it's all right here. So we have everything that we need just right here. So you'll see this pattern or for like the threaded hole and then these two holes here for the dowel pins. This is for alignment and also to prevent rotation. So those are important in our setup. And if you look at our drawing, you'll see similar hole pattern here. So here's what we're going for. We have a counterbore hole here to accept this low profile socket head cap screw to actually attach it to the gripper. We have a couple of holes here for our dowel pins to locate our gripper and also for the rotation. Down here though, we have a couple of conical holes. That is so we can insert these heat set threaded inserts. What this allows us to do is actually press these inserts into our print and use a bolt or a couple bolts to actually thread something on or fasten something onto the face of this print. Now these heat set inserts are really nice. We don't necessarily have to use them. Something that you could do is take a hex nut and essentially 3D print the space for the hex nut to go on the back and then thread this through just with a through hole, and you thread that into that fastener. Or you could just put the fastener on the back here, really, if you wanted to. The heat set inserts provide a really nice looking finished product. So these are really nice to have around and be able to use. We're using these for a couple reasons. One, so we can have the adapter arm here and then attach tooling as needed. The other thing is that it allows us to control how the two parts are printed. So notice that like on this part, maybe we had printed in layers going this way, right? This vertical direction. But in this part, we actually had layers going the other direction, the horizontal direction. So these would have been printed on the 3D printer in different orientations. That is something that we might do for the strength of the part or to save time on supports. So sometimes if you can divide up the part and then fasten them together somehow, not necessarily with like a nut and bolt, maybe with just glue or some sort of snap fit or some other method of fastening these together, then that might be the the best way for you to actually get those things printed. Not always, this isn't something you always have to do, but just keep in mind that that is available to you. You can split up the part and fasten them together. So this provides us a nice way to do that. Let's jump on in for our part. We are going to be in millimeters. So in NX, make sure our units are in millimeters. We have a model, name it end of arm tooling, save it to a location that you can access later. We'll start with a sketch in our right view. And we're going to be sketching the side profile first. We'll sketch this section first, extrude it at a distance of 20 millimeters, and then come in with our holes. So we'll go with our profile tool. I'll just start at the origin and rough out this shape. I'll start with the top line, going down a distance. And we have it going at an angle and then straight down. And then this sort of copies over this other side. We're done with the profile tool. Now, a couple things that I want here is I want this line and this line to be equal. This line and this line to be equal with each other. And I want these two lines to be parallel. So I added some constraints here. Before I do that, make sure that I have create persistent relations turned on. And I can go to my make equal, make sure that I have equal length selected. And I want the top vertical lines here, so the left and right, I want those to be equal. I'll say apply. And then the same thing for the bottom vertical lines, I want those to be equal. And I can say okay. And then I want these two lines to be parallel to each other. So I can say make parallel, and I'll select those two lines. Now we can go in and start adding dimensions. So this top line is 15 millimeters. The height here is going to be 20. For the bottom, height is 40. The offset, so from this face to our vertical axis, is 10 millimeters. And then the overall height of our part is 85 millimeters. So should we left something that looks like this? Our sketch is fully defined, so we can say finish. And we'll go ahead and extrude this a distance of 20 millimeters. All right, now we can start working on these holes. So let's do the M8 hole first. This is the hole that's going to actually connect onto this threaded hole here. So for this hole, we just need it to be a through hole that allows for a bolt to go through. So we'll make this a counter bore hole, and it's centered on the face along the vertical axis, and it's 7.5 millimeters from the top line here. So back in NX, we'll go to our hole tool. And the type that we want is a counter bore. Now on our drawing, it's specified that it's an M8, but if we were to look at what the M8 size for the diameter and the counter bore and depth are, you're not going to find these values. These values are special based off of the actual bolt that we're going to be using. So instead of going to the screw clearance, we're just going to stick in custom. and we're going to input our values. So we've got 8.4 millimeters for the diameter, the hole diameter, 13.4 millimeters for the counterbore diameter, and 6 millimeters for the counterbore depth. So that's 8.4 millimeters for the hole diameter, 13.4 millimeters for the counterbore diameter. For the counterbore limit, we've got value, and the depth that we want is 6. For the position, we'll go to the sketch section, and we're going to sketch on this face. So the top of our part and the face that is pointed away from the direction that the angle is going. So the stop face here. We'll say okay. I'll go and just place a point on the face, and we'll go and constrain this. It needs to be aligned with the midpoint of the top line. So we'll use our make midpoint aligned. Make sure that you have create persistent relations turned on. We'll go to make midpoint aligned. We'll go ahead and select our point, and then we'll select the top line here. If you can't access that top line, make sure that you have your scope changed to within work part only. And you can select that line. Now it's aligned at that midpoint. And we're also told that from the distance from this top edge to the point is 7.5 millimeters. So we'll go ahead and add that distance in. Sketch is fully defined. We'll say finish. Our depth limit for the hole itself should be a through body, and we'll say okay. Now the two 4 millimeter diameter holes for the dowel pins are located 12 millimeters apart and 9 millimeters apart, centered around the M8 hole. So what we'll do is we'll make a rectangle, constrain that to be centered along the center of the hole, and dimension that 12 millimeters by 9 millimeters, make that reference geometry, and then place the points on the corners of that rectangle. So we'll go to our hole tool. We can just do a simple hole here, custom 4 millimeters, and we'll go back to our sketch section, sketch on the same face. We don't need any points yet, so we'll just make a rectangle. We'll go to our make midpoint aligned, and we want this to be centered around the center of that M8 hole. So I'll select my top line, and then I want the center point of the M8 hole. So I was able to pick it up like this. If you have trouble accessing that center point, rotate around to the other side, and you can pick it up here. Any of these arcs are going to be fine. They're all the same. So you can select that circle, the arc center of that circle. We can say apply, and then we need to select one of the vertical lines here of our rectangle. So that one, and you can select the same one, and we'll say okay. Now we're located around the center of that hole. We can add in the distance here. So the top is 12 by 9. So this is a 12 by 9 rectangle. And this is reference geometry. So I'll select the 4 lines of our rectangle, and I'll convert that to reference. And then I'm going to add 2 points. So I'll go to the point. I'll add one to the top right, and then one to the bottom left. Sketch is fully defined. I'll say finish. Our depth limit here is through body. We can say okay. Yes, the 4mm holes are going to protrude through the counter bore of the first hole that we did. That's fine. That's what it's supposed to be. Now for our next two holes, this is going to be the holes for our heat set inserts. We have two holes for each. So one hole is going to be a tapered hole, and the other one is just a regular through hole. Why the taper hole? Well, if we go to the drawing for our heat set inserts, it actually tells us the hole size that it should be used for. So it tells us for hole taper angle of 8 degrees, maximum hole diameter, drill bit size if you're using a drill, but we're not, because we're 3D printing this part. So it tells us all this information here. Just go. This is going to change depending on what insert you're using, or if you're even using an insert. So, if you were using a different insert, these values would be different. So back in NX, so far we've been on this side for our holes. We're actually going to flip this over. All right, and we're going to actually we want our holes to be on this side of our part. So we'll go to our hole tool. We want tapered hole. The hole diameter that we want is 8.026. And the taper angle is 8 degrees. And we'll go to our sketch section to specify the position. And the plane that we're going to select, the face that we're going to select, is this face here. Notice that we have been on this side. Now we're going to be sketching over here. So it's the other side of the part. And on the bottom of it, not on the top. We'll say okay. And we're not going to place any points yet. We're going to use a similar method that we use for the 4mm holes. So we're not going to do a rectangle, we're just going to do a line. I'm going to go to line, and I'm just going to make a vertical line here. And then I'll constrain this so that the midpoint of this line is centered on this face. So I'll go to make midpoint aligned. And I want to select the midpoint of the line that we just made. So make sure we pick up the midpoint. And I want that to always be aligned to, you can select this bottom line. You can also select the top line, but bottom line's right there. I'll say apply. Same thing, I'll pick up that midpoint. And I want that to always be aligned to our vertical line. And I'll say okay. So I've aligned it to the center of this face. We're told the distance between the two holes is 16mm. So change the length of that line to 16mm. Now it's fully defined, but this isn't what we want. So we're going to convert this to reference and place a point at the start and end of that line. Now we can say finish. And that's defining the locations for those holes. The depth here is a through body. We'll say okay. And we'll add 2 more holes here. So we'll go back to the hole tool. We can just do a simple hole. Hole diameter of 5mm. And we don't need to go to our sketch section again. What we'll do is we'll just pick up the center points of the holes that we just made. So I'll approach the hole here, and I'll make sure to select the center, the arc center. And when I do, it gives me an alert. It says unable to find face of target body for direction. Because we've just selected this point out in space, NX doesn't know if the hole that we've selected it's going down or up or left or right or at a weird angle. All it knows is that the center of the hole is here. So we need to tell it the direction. So on the direction where it says normal to face, we're going to change that and say long vector. Now we have to specify the vector. Easiest way to do this is to just select the face of the hole that's already there. So we have the face. So it's gonna pick up the vector of that hole, and that's what we want. I'll go back to specify point because I want to pick up the other hole as well. I've got both those selected. I can say show results just to see. All we're looking for is that essentially the bottom of that conical hole is just going to be a simple hole. So it doesn't taper out all the way. This allows us to still get good contact for the heat set insert. But if we have a really long bolt, it's still going to go all the way through. So we'll say okay. That's what we're looking for there. And the last thing that we have to do is we have this R3 edge blend on the corners. So we'll go to edge blend with a radius of 3 millimeters. And it's on all 4 corners of our part. And we can say okay. Now, to do something like that, you have to have an understanding of the print orientation. So whether the surface, essentially of how you're going to print this part. So if you would be printing this part to where like this surface is on the build plate, then you wouldn't want to do edge blends like this because you would be building up layers on this surface here. A chamfer would be much better for that. So before you start modeling anything for 3D printing, you really have to know how you're going to be printing it on the print bed. And to know that, you have to also know, what forces are you expecting on this part. So for instance, if we printed this part vertically, right, we'd have these individual layers, going up our part. If this gripper closed, right, essentially we'd have a good bit of force down here, probably, trying to split those layers apart, and it probably wouldn't last very long. But if we printed it in this orientation, now the layers are going horizontally here, and the forces, again, would be trying to push this apart. But since the layers would be vertical at this point, it's much less likely for this part to fail. So we want to keep stuff like that in mind before we even start 3D printing something. And of course, this depends on the type of 3D printing that we're going to be doing. The material that we're going to use. All of that needs to be worked out before you even get to this part here. So go ahead and save this file and submit it to the Dropbox on Canvas.